So, first of all, thank you, Damon, thank you, Tony. It's an honour and a privilege to be here on the inaugural meeting. And I'm going to make this pretty fast, and I don't know kind of the mix of people here, so I've got some introductory slides. I'm going to talk about Chronos, how and why we made the spec, and then Ken's going to get on. Ken Russell, who's my co-presenter here, who's from Google, is also the chair of the WebGL working group at Chronos, is going to give us some demos. And then we're going to get on to more demos from Henry. So, because this is an inaugural meeting, I did some PowerPoint archaeology. This was actually the earliest slide I could find.
I am so glad you did this. Thank you for doing it. So
this was from SIGGRAPH 97, where we actually launched the Vermal Consortium. And it is going to be different this time around. But actually, it's not so much we're throwing away everything that we've been working on for 17 years. We wouldn't be here with the opportunities and the community and the friendships and the commercial relationships that we have that's going to make WebGL great unless we've gone through the experiences for the last 20 odd years. So, but it is kind of interesting. SIGGRAPH 97, it's here and ready for business. We're getting there eventually. So, what is different this time around? When we were trying to make Vermal a success right back at the beginning, we had the right vision, and that is to bring 3D onto the web. And why is that the right thing to do? It unleashes 3D, it democratizes 3D, and it unleashes innovation of hundreds of thousands of developers that otherwise probably wouldn't have the capability or the opportunity to use 3D technology. And Ken and I were talking on the way up, and he was showing me some demos here. I was going, holy moly, how did you do that in WebGL? The stuff I never imagined you could do in WebGL, because now we have many more people using and looking at the technology. It's just a wonderful thing. Remember back to the Web 3D Roundup days, was the energy of the opportunity of bringing 3D into the web. It inspires people, and we're going to be there again. But it is different this time around because 3D is pervasive. 3D's been on PCs for a long time, and Macs and Linux on the desktop, but now 3D's in mobile. And mobile is the platform of the 21st century, PCs are the 20th century, and already 3D is everywhere. And we're fortunate in the 3D space that unlike lots of other media data types, we have a consistent standard across all the different phones. It's OpenGL ES. This is a pretty bar graph from John Petty, who lives down the road, 3D market analyst. He's basically saying anywhere that there's a mobile device, not just phones, but tablets, embedded systems that are browser capable, you're going to have 3D, and it's going to be consistently OpenGL ES. That is one of the catalysts that makes the 3D capability interesting to the browser vendors, because of course browsers have to run everywhere. That's one of the main raison d'etre for a browser, is you can deliver content reliably wherever you are. And if 3D is not there underneath the browser, it's really not a viable proposition. For the first time, we have reliable 3D. And for those of you that are not familiar with OpenGL ES, there's a couple of versions. Yeah, go ahead.
What was the unit in the bar chart?
I have no idea.
Awesomeness.
Like what are the numbers?
So the numbers are 100 millions of shipped units.
Oh, units, devices.
Per year. So mobile phones is getting up to close to 1 billion units per year. And the orange is how many are getting there. So pretty well any smartphone or superphone now has 3D. And there's about 1 billion of them shipping a year. So for those of you not familiar with OpenGL ES, there's a couple versions. 1.1 is a streamlined version of OpenGL 1.5, it's a fixed function. The interesting sweet spot that we've hit is with OpenGL ES2, which is a streamlined version of OpenGL 2.0. So you get programmable shaders, vertex shaders, and fragment shaders. It's through luck or judgment, we've kind of hit the sweet spot that lets people do most of what they want to do in an API that is simple and cheap enough to put into 1 billion smartphones a year. And if you look around the various mobile devices that are shipping, a whole bunch of different vendors. They're all consistently using the same API. Meanwhile, in the browser domain, HTML5 has been evolving, and the technologies, the ingredients that make up a state-of-the-art HTML5 browser have been evolving too. And the stars have kind of aligned to make WebGL possible. So, I'm sure there are many people who know a lot more about this than me, but a classic browser, you have the major components. You have the layout engine, it's taking the HTML into the DOM, the database. You have the JavaScript engine, gives you the interactivity, reading and writing the DOM. And you have the CSS, which does the presentation of the content onto the web page independently of the content itself. And the big thing that's been happening over the last 5 years is the JavaScript virtual machines have been getting much, much, much faster by orders of magnitude. And the other big thing in HTML5, which is very enabling for WebGL, and came before WebGL, is Canvas. So a surface that for the first time you have pixel level rendering control. So you can not just draw text or video or pictures, you can actually render pixel by pixel. So there's all these things come together to make WebGL possible. It's kind of a historic opportunity that all these stars have aligned at this particular point in time. So as Tony says, WebGL in essence is a JavaScript binding to OpenGL ES2. So anything you can do in OpenGL ES2, almost anything you can do in OpenGL ES2, you can do in WebGL through the JavaScript binding. We're leveraging the Canvas element in HTML5, but rather than using the standard API, which is 2D vector graphics API, we can now declare a 3D context for the Canvas and draw the 3D graphics. So WebGL has been defined at the Chronos group. We're fortunate in having all of the browser vendors participating, and that's the other really big difference between this time around and the last time around. The first time around, it was the 3D community saying, we really know we want to have 3D in the browser, but the browser vendors weren't interested, really, in the end. Though they teased us for a while.
They teased us for a few years.
This time around, it's the browser vendors saying, we want 3D in the browser. Can we work together to make it happen? That's the fundamental difference. So you've had Mozilla, Apple, Google, Opera working together, closely together with the GPU vendors to make WebGL happen.
Just missing one browser.
Yeah, it seems like you're missing.
Yes, I'm glad you asked. Well, someone was actually, I don't think it was you, but it was someone else from Google, as Google likes to say, unofficially, all the leading browser vendors are implementing WebGL.
Isn't IE9 kind of on board now?
No.
No. So Microsoft are doing some HTML5, but not all of it. We do have a short-term tactical, actually there's a couple of short-term tactical fixes. Chrome Frame is probably the best one, where you can use the Chrome rendering engine, which includes WebGL within IE9. So that will be probably the short-term recommendation. Obviously, the longer-term hope is that Microsoft will adopt this open standard. There's no barrier. They will be welcome with open arms to join or use the technology. So, fingers crossed.
It really only matters if people have PCs.
Little fuddy-duddies. So now we have the advanced content types for HTML5. We have the video tag. We have the canvas tag, which is for vector 2D, being driven from JavaScript. Now we can use the JavaScript to drive 3D content too. And 3D, 2D, video, and your classic HTML all being blended and composited together onto your web page. So how is a WebGL browser actually implemented, and how does the content reach the web page? So all of the WebGL capable browsers are relying on the drivers in the system. There has to be a 3D driver in the system somewhere. The working group has been working to have quite some flexibility on what drivers can be used. in a WebGL implementation. Obviously, if you're on a mobile device, you'll have OpenGL ES2, and it's fairly straightforward. You can use OpenGL on a desktop system, and the latest version of OpenGL, OpenGL 4.1, actually includes an OpenGL ES 2.0 context. You can actually ask for a compliant, conformant OpenGL ES2 context from the latest generation of OpenGL desktop drivers. But there are some systems where there's not a reliable OpenGL available. Some of the older Windows systems, and Google have a open source project called Angle, which implements OpenGL ES2 over DX9. So if you find you're on a system that is proven to have a reliable DX, but not OpenGL, you can still give yourself an OpenGL ES2, and then the rest of the stack continues to work.
Just in case, is there going to be a full software fallback?
Depends on the browser in there, right?
Google, we are hoping to find a software solution.
Okay.
In previous products, we licensed Transgaming Swift Shader Engine, which is a pretty fast implementation direct from the including shaders. And so we're investigating that as an option.
But it will depend on the browser, and it will depend on the platform that they're running. So if it's an embedded system where they know what's there, you might not need it. But it's true of all of the Chronos specifications that hey, how come all of the, no, it's okay.
Those
You
three
knew what I
names.
was going to say.
Totally different.
What was I saying? I don't know, I forgot. It doesn't matter.
I hear you, brother.
So the key thing is that WebGL is implemented by the browser vendor. And this is why we don't need a plugin. It's fairly obvious, but fundamental. And the fact that it's the browser vendors themselves implementing the WebGL functionality along with the HTML5 and JavaScript and the CSS. The browser vendors have become 3D engines. This is kind of the key shift. Then you bring down the content from the network. Either you can bring down content that uses WebGL directly, or you can go through middleware layers, and there's actually already a rich diversity of middleware. Probably some of you here are involved in making some of that middleware. And this is where kind of the circle goes full right around, is that some of the middleware is indeed based on X3D, and making the middleware at a higher level rather than the low-level OpenGL ES binding, which is very familiar for everyone who's done 3D, but if you're not a 3D programming expert, it can be quite a large learning cycle. To be able to use something like X3D, which is XML based, much more familiar to lots of web developers, it can be very enabling to have a lot more developers having access down into the lower level WebGL engine. There's probably 30,000 real expert 3D programmers in the world. There are millions of web developers in the world, so it's critical that we have the middleware to enable that larger community to tap down into WebGL. And to me, the most exciting thing about WebGL is that it's not 3D trapped in a rectangular prison. It's really part of HTML5 itself. It's an intimate part of the browser stack. You can underlay and overlay the 3D and the 2D, so you can use 3D content with a 2D user interface, or you can use a 3D user interface over 2D content. You can feed canvas into WebGL as a texture. You can feed the video tag into WebGL, so you can use the power of the 3D graphics engine for doing anything in your web page that you wish, not just doing the rectangular content in isolation. 3D manipulation and 3D technology becomes an intimate part of your web stack that you can use however you wish. And I'm hoping that we're going to see not just 3D content, but 3D user interfaces that really make the web a lot more accessible and a lot more interesting to use. So, some history for those that are interested. The WebGL started the working group in March 2009. We've done it pretty much in the open. It's a web standard, so most of the Chronos specs that are driving silicon, which tends to be rather hush-hush, was done behind closed doors, but because this is a web standard, the WebGL working group decided to do it out in the open with a lot of interaction with the community, which I think really paid off. We've had provisional implementations out there using draft specs since early 2010. There's a bunch of middleware that I mentioned. There's some of them that's more than an extensive list. Apologies if yours is left off. There's an extension registry online, and the big news a few weeks ago at GDC March 2011, we finalized the 1.0 spec, so it's now official and released, and the browser vendors are making progress to implement the spec. Some of the status on the various browser vendor implementations are right there.
We're still waiting to hear on mobile Safari. We don't know yet. Or the mobile stuff.
I don't know. Are we allowed to say?
Well, I believe that it's been publicly mentioned that the support's actually compiled in, but it's not enabled for public web pages.
Accenture did a pretty deep review of the latest iPad 2 browser that shipped, and that has the top of the tree version, and that has it there. It's just need the on button to be pressed.
In all fairness, the reason that Apple is concerned about turning it on by default is that there are situations where maybe the graphics driver isn't quite as robust as you would like in the face of content that pushes it to its needs, basically.
Apple's drivers are the least robust.
Really? Well, this
For our
is
apps.
okay. This is news to me, and I'd like to understand, how
So what I would like to understand.
Anyway, we're hoping to get all the driver vendors to make their drivers much more robust, which will give a good underpinning for this technology.
Right.
Can I ask about that? Because that's one of the things that, we have some customers for some of our stuff that are very mainstream, and they really suffer on these older computers. And is there a sense that now that WebGL is really sort of gathering steam, is there a sense that now you can talk to people who wouldn't pay attention to you in the past? Or maybe I should ask you actually.
But, I mean,
Yeah.
from the silicon vendors, probably NVIDIA had on for a while. Yes, definitely. Now, the silicon vendors are definitely taking notice, and some of the issues, like the security issues, are actually being firmly discussed now. Saying, oh, no, WebGL is also going to be important. We need to get the GPU to be as robust, first-class computing device as the CPU has been for a long time. So it's definitely impacting our universe. But the interesting thing is WebGL doesn't exist by itself. There are other related standards that Chronos does. I don't know if anyone knows what a Chronos is. Well, a Chronos is an industry consortium. We have about 110 members, different companies. We come together to cooperate on stuff that's going to help good stuff happen. So building open, royalty-free standards, mainly for graphics and media type stuff. Because we're seeing that there are millions of devices out there with this cool capability, but we don't grow the market until we deliver actual, real, exquisite end-user experiences. But that means that we have to get the developers connected to the silicon. And the only way to really do that is to have these open standard APIs that all of the silicon vendors can agree on and implement. When you get that level of cooperation to build the foundation, then we can all go off and compete in the marketplace with building our own implementations of those standards. So we have some related standards. I'm not going to go through all of these. We have around 18 standards right now that Chronos is working on. Of course, OpenGL is related to OpenGL ES. It's the granddaddy of OpenGL ES. We have OpenGL, which is a parallel compute API that some of you might have heard of. We have Collada, and we have the father of Collada in the room, so Remy. Collada is the one standard that we do that's not an API, it's a file format. It's a 3D asset interchange format based on XML. We have WebGL, of course. We have a new working group called WebGL, which I'll talk about in a second, but you might guess it's connecting JavaScript into OpenGL as opposed to OpenGL. It's very new. We don't have a spec yet.
Do you have like an estimated timeline? Or
not yet. And it's really going to depend on, to a large extent, we have to solve the security issue for WebGL. OpenGL has an even bigger security issue because it's basically C99. with some subtractions. But if you can wreak havoc with WebGL, you can do it much more with WebCL. So we really got to figure out that security issue before I think WebCL will become mainstream. But it's good that we start figuring it out. And the interesting thing is, now we have WebGL. WebGL is, this kind of goes to your point, it's become part of full-class citizen in the OpenGL ecosystem. So we have now these three different flavors of OpenGL. We have OpenGL on the desktop, and the leading edge high-end functionality comes in through the OpenGL API. OpenGL 4.1 is probably slightly nosing ahead of DX11 now in terms of raw functionality. We stream that down to make it accessible to the mobile devices. Now we have WebGL that's using that pervasiveness, but now WebGL is beginning to feed back into OpenGL. The security issue and other issues too are really beginning to have an impact on the way that the desktop OpenGL is being designed going forward. So we have this kind of cool ecosystem building, and OpenGL in its various flavors is easily now the most widely deployed 3D API, much more than DX11. It's everywhere, and that makes it cool, I think. So I wanted to mention just a couple of the other standards. The Collada is key. It's used in a lot of the authoring pipelines, lots of the models. Henrik might talk more about this. One of the things we wanted to mention, something that we launched at GDC, is we have now a set of conformance tests for Collada import, export that are free. So go check them out. It's actually quite a comprehensive set of tests. If you're importing, exporting Collada models, download the tests and you can make sure that you're being a good Collada citizen. And I mentioned WebCL earlier. We have just started. The use cases, once we get WebCL working down the line at some point, the use cases that people are interested in are physics engines running next to WebGL for gaming, video editing, image editing in your browser, tapping into the power of the GPU in a way that isn't currently possible in your web browser.
What's the timeline on WebGL? I mean, I know it's when it's ready, but like, what would be your best guesstimate?
Like when we can get an early build, or is it better if we're doing stuff like that to go ahead and use like a native client?
Well, there are prototype builds today from various vendors, but I mean the browser vendors are not committed to do it yet because of the security and potentially other issues too. So you're not going to get it in any builds from the browser vendors, but you can do it as a plugin potentially. I think plugins will appear perhaps quite soon.
But I mean, you could write a plugin and just access and call Nate OpenCL if you wanted to.
Through JavaScript.
Yeah.
Right. I would guess you'll probably see
like
those this year. Yeah. So that's the end of the slides. I want to get it over to Ken. Oh, you want to go first?
I'll go for it. I'm sure we got a soft end to this. Just go for it while you have the computer.
Actually, it's getting canceled. Why don't you go ahead.
Okay. That's
Right.
cool.
So
Then I won't have to worry about his demos being cooler.
any questions before I finish? Yeah.
Well, first of all, I'm not a very tech savvy guy, so excuse me if I'm doing something like that. What I'm interested in is this visualization technologies, browser or mobile visualization, the 3D visualization in content. Would that work differently than the collaborative creation of content in the browser? Would that need specific type of other extension to this technology? Or by using this standards, can we also afford people to create their own content via the browser?
Anything you can do in OpenGL ES with a C program, in theory you can do with JavaScript and WebGL. So if you want to make a authoring program running in your browser, that's certainly possible. That you're not missing any crucial functionality.
That was a better wording of what I'm saying.
There are a couple
In
other
fact,
things going on.
Henrik's going to show something quite like that.
Right.
Yeah, I know a
Right.
little about Henrik's project, and I'm really looking forward to seeing it.
Right.
There's a couple of other standards being worked on that weren't mentioned vaguely in the HTML5 umbrella. One is WebSockets, which
especially if you want to do real-time multi-user game kind of collaboration.
Right, because that's the really significant thing about HTML5. It's not that it's the next version of HTML. That's kind of important but kind of boring. It's the fact that the browser is becoming a first-class computing platform with access to all of the things that you would in the past have to use native APIs for, like persistent storage and networking. It's all gradually coming into the browser. So literally anything you could do, you can use HTML5 to do in a portable way.